Hello, and welcome to this vSuite version 0.3 video tutorial, which is the second in a series of EnVi video tutorials. And in this video tutorial, I'm going to cover how to do some sort of services specification, or to provide some details of the operation of the simple EnVi zone that we created in the previous video tutorial. So I'm starting pretty much where I left off in the previous video tutorial. I've got my room, I've got my EnVi node set up, and I've simulated this room, and I've produced very simple temperature data for this room. But that's not very realistic. Usually buildings have a level of heating or cooling or occupancy, etc. So let's specify some of those things for this particular zone. So I'm going to split my node editor window into two, make this a little bit bigger. And on this side, I'm going to keep my main vSuite node tree. And on this side, I'm going to move to the EnVi network node tree, which is signified by this windsock icon. And as I've previously done an EnVi geometry export, I should find that I have an existing EnVi network within this node tree, and this EnVi network will have one node in it, and that is an EnVi zone node, and it's created automatically based on the EnVi zones I have specified when I clicked export on my geometry export. And this EnVi zone node has got the name of the Blender object, name of the zone. It's got a guesstimate of the volume of that zone, and we have a control type menu here, which I'll come to a little bit later. The main thing about the node is it has these input sockets for HVAC, heating, ventilation and cooling, occupancy, equipment and infiltration. So let's say, for example, that I have a heating system within this room which is going to try and keep the temperature at 20 degrees Celsius. So I need for that an HVAC node to connect to this HVAC socket. So add, and in my zone nodes I've got a list of all the relevant zone servicing nodes, and I create an HVAC node which now connects to the HVAC zone socket. So by default we have no heating system and no cooling system designated, but I can change that. So I can change, because EnergyPlus is an American piece of software where the heating and cooling of buildings is often done via air. The heating and cooling systems applied within EnVi sort of relate to the supply of either hot air or cold air, depending on whether you're employing a heating or cooling system. So we can limit the flow rate of this heating and cooling air, or we can limit the sort of heating or cooling capacity of the air that's being supplied, or we can limit both, or we can have no limit, and the system will just produce as much heat or cooling as required to maintain the temperature that we specify. So for the moment I'll probably say I'm just going to limit the flow capacity. I'm going to limit the flow rate. So if I limit the flow rate, the options that then become relevant are the temperature of the air that I'm going to supply to the space, and I can say 50 degrees Celsius. And I'll mention now, although the building that you model may not have an air heating system, the purpose of this sort of process is to define the overall heating and cooling requirements for a space. So it doesn't really matter in what way the heating or cooling is being supplied. All that's going to happen is, in this case, heating and cooling is going to be supplied by an airstream to maintain a temperature of 20 degrees Celsius. and from that we will get an overall heating and cooling value in kilowatt hours in terms of energy. So even if your building doesn't employ an air heating or cooling system, in terms of only working out overall energy consumption, this is still a valid approach. So the heating and temp, I'll keep at 50, that's fine. I can now also specify what's the maximum rate of air that's going to be supplied to the system, and that is in meters cubed per hour. So I'm going to put that at half a meter cubed per hour, or 500 liters per hour. And then we set the thermostat level. So if this level basically says, if the room is below this level, we will employ this heating system to bring us up to this level. Beyond this level, above this level of 20 degrees Celsius, the heating system is shut down. It's only there to bolster the internal temperature up to 20 degrees Celsius. So that's fine. And if we were looking at an MVHR system, we could specify some heat recovery here. But at its most simple, that is the only metrics we need. The other options for the moment about cooling and how much of this air being supplied is from the outside can be left as none for now. We have some input sockets on the HVAC node. One is to specify the schedule of when this heating system is in operation and not. So if it was a commercial building, for example, and the heating system is only in operation between 9 and 5 on work days, we could specify that schedule for this HVAC system. We can also specify a schedule for the thermostat set point for the heating system, and if we've chosen cooling, for the cooling system. And I might play with a few of those options in a minute, but otherwise that's enough for an extremely basic heating system to be employed in the building. So if I come back to this node, I don't need to export the geometry again, because these definitions apply to the geometry on layer 2. They don't apply to the geometry on layer 1. They don't apply to this geometry. They apply to this geometry. So I don't need to export the geometry again, but I do need to re-export the EnVi context. So if I re-export that, I calculate again, and if I maybe put this back on hourly and plot that again, you can see now our ambient temperature is still the ambient temperature, but our building now doesn't go below 20 degrees Celsius for the level of heating that we have applied. If I reduce the airflow rate of the heating system, maybe to 0.1 meters cubed per second, again, export the context, redo the calculation, and create that plot. Oh, that's still enough to keep the building at 20 degrees Celsius. So let's try even less, 0.01. And now we see there's a little bit of an effect at the 20 degrees Celsius line, but the heating capacity of the system now is too low to maintain the building at 20 degrees Celsius all year round. So that's fine. I'll put that back up to 0.5. Now, because I have a heating system applied, I can now select heating watts as a metric. So if I export that again and calculate again, we'll see that we've got a new metric appear within our list of metrics. I'm going to turn off the climate because the climate temperature doesn't relate on it's not on the same numerical scale as the heating. I'm just going to look at the heating temperature, or the heating watts required or used by the building. So there we can see now the heating watts that the building needed to maintain a minimum temperature of 20 degrees Celsius. So as you can imagine, that heating requirement is much higher in winter. When it's colder outside, we've got more heat losses through the fabric of the room, and we need to replace those heat losses with our heating system to maintain 20 degrees Celsius. If I wanted to install a cooling system, I can do the same thing again. I can have a cooling system. I can choose, if I want, limit capacity rather than limit flow rate. Limit capacity means there's a maximum capacity in terms of watts that the cooling system can apply. And that cooling system limit is set here, and that's in watts. So I might keep that at 1000 watts or a kilowatt. And my thermostat temperature, I'm going to say, is 24. So anytime my room goes above 24 degrees Celsius, my cooling system kicks in with up to a kilowatt of power to remove heat from the space and keep it at 24 degrees Celsius. So I can now turn on cooling watts, export, calculate, and once that has done, I can now plot, as well as heating watts, cooling watts. I can look at those too. I'll change the color of one of the plots just so that we can see it a bit clearer. And we can now see our heating watts are in black and our cooling watts are in red. So our cooling system only comes on in summertime, as you can imagine. But we can see that we've set a maximum capacity for that cooling system at 1000 watts, and it reaches that capacity. That does imply that the building does still reach higher than 24 degrees Celsius temperatures in summer. So we could just check that. Now, why are you not letting me? I've left. Excuse me, I've left the other window open, I guess. I've left the settings window open somewhere. There we go. I can now test if that's the case. I can just change this to temperature, create that plot, and yes, you can see that although the cooling system does have some effect at maximizing temperature at 24 degrees Celsius, there are still times when the temperature is above that. The sort of details of the options within this node and the scheduling of the when the system is on and off, and the heating and cooling temperature set points, that's kind of covered in the EnergyPlus input-output manual. I will just show you how to add a schedule. It's in the Schedule Nodes menu. So I might say this is a schedule that's going to apply to when the heating and cooling system is in operation and not in operation. The Schedule node says up until, from day one of the year, up until what day of the year is this particular schedule valid for. And it defaults to 365, the end of the year. If I set 180 and I set, let's keep it on 365 for a moment. So these two further dialogues relate to the whole year. And in the fors dialogue, I say for what kind of days. So I might say weekends, and I might say weekdays. It's a space-separated list of the kinds of days. And the complete valid list of the types of days you can have in there are in the vSuite user manual. But let's pretend this is a commercial building and I want there to be the heating on during the weekdays and off during the weekends. So this button, or this entry field, for each of these day types that I've specified, I can now specify a time and a value for the schedule. So I might say for the first weekends from, and again this dialog starts at midnight, so from midnight until 8 in the morning my system is off, and I represent that with a 0. And then I use a comma to then say for the next time period, and that might be then from 08 to 6 o'clock in the evening, the system is now on, which I represent with a 1. And I comma again, and I say till 24 or midnight, the system is off again. So the last number should always be midnight because we start automatically at the previous midnight. So that covers a whole 24-hour period. That's then for the weekends. For the weekdays, and I've actually done it the wrong way around, I'm sorry. I've specified a weekdays heating system when it should be weekends. So I'm going to specify weekends first. The way we separate between these two day types is with a semicolon. So now I'm going to say 24, so the whole day, it's simply 0. So at weekends, for 24 hours, it's 0, and for weekdays, up until 8, it's off. From 8 till 6, it's on, and then from 6 till midnight, it's off again. So if I press enter on that, the node should go grey to say, yeah, okay, that's a valid schedule that you've entered. If I was to now say, this schedule only runs for the first half of the year, then I would get another set of options to fill in for however the schedule has changed for the latter half of the year. And I can have, I think you can have up to 3 ranges of the year in which you can set different schedules. But for now, I'm happy to have one schedule for the whole year for the weekends and weekdays. So again, if I now press export, calculate, and create plot, we can see now quite clearly that at the weekends the heating system is not in operation. So we often come down below, and indeed in the mornings and evenings of the weekdays we're not supplying heating to the building, so the temperature now drops below the 20 degrees Celsius thermostat level. But during those times when the heating is on, we do achieve that 20% level. Occupancy is done similarly. I'll just collapse these nodes down for the moment. Occupancy is done in a similar way. That's a zone node, occupancy node. We have lots of schedule nodes here where we can specify the schedule for the occupants themselves. We can specify a schedule for activity, work efficiency, air velocity, and clothing. All the things that you require for a comfort calculation. We can turn on comfort calculation here, and once we've turned on comfort calculation, we can also turn on CO2 monitoring, which I guess I could do now. Actually, I won't do this now because we don't have a ventilation system set up, and I'm going to do that in the next video tutorial. So I'm going to turn that off. But again, process is fairly similar. We can pick what kind of occupancy we have. So I'm just going to go with number of occupants at the moment. I can specify the maximum number of occupants that there will be at any time, so 10. And then I could introduce a schedule node to say what proportion of those 10 people are there for different times of the day. So if the schedule node said 0, there'd be no people. If the schedule node said 0.5, there'd be 5 people. in the space at that time. In a way, because the occupancy schedule is going to be similar to the heating schedule, I can just copy this schedule node, bring that to the occupancy schedule node, and I can say, yes, actually that's perfectly fine as it is. So whereas 1 and 0 were turning on and off the heating system before, 1 and 0 now is specifying 0 people and 10 people. So that runs in accordance with our heating system, or at least I'm going to keep it so here. So we can set the activity level, watts per person. So 90 is a fine default for a commercial environment. So again, I can export that context. I can calculate that. And we can plot that out. And you start to see some slightly higher temperatures than 20 degrees Celsius appearing in places. And this is because the combination of the environment and the internal gains of the people is giving us higher than 24 degrees Celsius, even in sort of parts of the year when the outside temperature is less than 20. And we should then see also an impact on, for example, the heating consumption required in that space. So we can see when the heating is off, and these levels now, when people are in the building, are much lower than they were for the initial simulation. So that's pretty much, we can set sort of constant or scheduled levels of internal equipment heating gains, and we can also specify a simple ventilation infiltration coming from outside into the zone as well. But for sort of the basics of zone specification, I think that's all I need to cover. Okay, thanks for watching.